Hello everybody. Today we are going to continue our chapter about exponential function part 4. Let's study now the variation of the function fx equals ex. The domain of the function f is from minus infinity to plus infinity, and we have studied this in the first part of our lesson. Second, the derivative f prime x is equal to ex, but ex is always positive. We have proved this also in the first part. And if the derivative is always positive, this means that the function is strictly increasing over its domain. Now, particular points. The particular points, usually we take some particular points like x equals 0, for example. If x is equal to 0, so e power 0 is equal to 1. So 0, 1, 0, 1 is a particular point for this function. Let's move now to the limit. Usually we study the limits of the function at its boundaries. The boundaries of this function are minus infinity and plus infinity. So the limit of ex as x tends to minus infinity is equal to e power minus infinity. It is equal to 1 over e power plus infinity, equals also to 1 over infinity, which is 0. And we have proved this limit in the third part of our chapter. In the third part of our chapter when we studied the limits. Then x-axis is a horizontal asymptote. When x tends to minus infinity, the result is 0. This means that y equals 0, which is x-axis, is a horizontal asymptote. Now the limit of ex as x tends to plus infinity is equal to e power plus infinity. It is plus infinity. And the limit in this case, we have to study the limit of ex over x. When the limit of the function as x tends to plus infinity is equal to plus infinity, in this case we move to what? To the limit of the function fx over x as x tends to plus infinity. Let's study the limit of this. We have found this limit before in part 3. I may use here Hopital's rule, and I may use what? I may say that ex is faster than x at plus infinity. Then the result will be plus infinity. Now, the limit of fx over x as x tends to plus infinity is equal to plus infinity. This means what? Graphically, this means that y-axis is an asymptotic direction. Y-axis is an asymptotic direction, as you see here. Let's go now to the variation table. X, f prime x, fx. From minus infinity to plus infinity, the derivative is always positive, and the function is increasing. From what? From 0. Why it's from 0? Because at minus infinity the limit was 0. At plus infinity the limit was plus infinity. So it's strictly increasing from 0 to plus infinity. Let's go now to the graph. Here in our graph we have 3 graphs. Actually, I'm interested now in the graph of y equals ex first. As you see here, at minus infinity, so when x goes to minus infinity here, fx goes to 0, so x-axis is a horizontal asymptote here. It passes through this point, which is 0, 1, then it increases indefinitely. It increases indefinitely. It seems to be parallel to y-axis. Why? Because y-axis is an asymptotic direction, as we have said here. Y-axis is an asymptotic direction. So this function, it increases indefinitely, and it seems that it is parallel to y-axis. Y equals x. This is the first bisector. And as you remember, this is the graph of what? Y equals ln x. And we have said that in the first part, y equals ln x and y equals ex are inverse functions, of each other. As you remark that this point is the symmetry of this point. This point is a particular point, belongs to y equals ln x. It is 6, 1.8. And this point, it is what? 1.86. So if this is xy, this will be yx. And you remark here, this point is 1, 0. This is a particular point of y equals ln x. Its symmetry with respect to y equals x is 0, 1. And as you see, these two graphs are symmetry with each other with respect to y equals x. Like this, we have finished our chapter about exponential function. I want to say one remark before I finish my lesson. Remark that ln x is less than ex. Graphically, I may notice this remark. Ln x less than x graphically means that ln x is below the graph of x, as we see here. This is the graph of ln x. it seems to be below the graph of y equals x. And y equals x by its turn, it's what? It is below the graph of y equals ex. So I can remark the following: len x less than ex, and I may use this property in any exercise about limit or about anything. So this is a fact. Len x is always less than x, is always less than ex. And sometimes in extra exercise, they ask me show this property. We will see this later. Thank you very much. Like this, we have finished our chapter about exponential function. See you later. Thank you very much.